Start recording. Yeah, now I'm starting to present, but it's still going to take some time. Yeah, you should be able to see this PPT. Okay. So in the last class, we had introduced the problem of obtaining how to attain a distribution of commodities in society. Okay. So we have some individuals. I'm sorry, I've hurt my hand. I can't write properly. So we have, let us say, two individuals, A and B, and we want to attain a distribution of commodities or ensure that the utilities of A and B are such that it's not possible to improve the situation. Okay, now we can have two structures. In one structure, we allow interpersonal utility comparisons. So in that case, if we have a situation like this, 5-10, so one person is gaining, the other is losing. We can compare the utility gain or utility loss of different persons. So we can compare whether A gains and B loses. We can compare their respective gains and losses and arrive at a conclusion that the new situation is better, or it is better to remain in the status quo. So that is one possibility where we allow for interpersonal utility comparisons. The problem is that if we introduce such comparisons, then the analysis is going to be subjective. In the previous class, you had seen that we could arrive at different conclusions depending on a position. So this was the main criticism by Lord Robbins. The alternative is that we do not allow interpersonal utility comparisons. In that case, it is possible to identify efficient points using the Pareto criteria. Okay, what is the Pareto criteria? A Pareto optimal equilibrium is a state.
So that one cannot be made better off without the other
Yeah,
getting worse off.
where yeah, where we cannot improve the position of one person without adversely affecting at least another person. So a Pareto superior state is there are some persons who are remaining in a status quo position, but we can always identify one person who gains. No one loses. There are some who are remaining in the same position, some gaining. Pareto inferior will be that you have persons in the status quo, no person is gaining, but some people are losing. So now the question is that how do we identify whether a equilibrium is Pareto optimal or not? What are the conditions? And we are going to look into we are going to use a 2 into 2 into 2 model. We have two inputs, labor and capital. The amounts of total amount of labor, total amount of capital is given. It's a closed economy, so we cannot import. We have to, these labor and capitals are used to produce two commodities X and Y, which are consumed by two consumers A and B. So what are the constraints? I've already mentioned one constraint, the fixed endowment of labor and capital. The other constraint is technology. And the technological constraint is given by the production function. X as a function is a function of Lx and Kx. Y is a function of Ly, Ky. Okay. Now let us divide the problem into three parts. First, we will decide on how much to produce. Okay. Now, it is what is an efficient production point, right? So far, what we had done was we had defined Pareto optimality in terms of utility. We have two persons, and we are talking about utility. So, I have written the definition over here. In the context of production, we can see that we cannot improve production of a commodity X without reducing the production of some other commodity. So that means an equilibrium is said to be Pareto optimal if an increase in X is possible only by reducing the production of Y, and vice versa. If you want to increase the output level of Y, we have to reduce the output level of X. How do we find it out? Okay. Now here we have to introduce the yes.
Can you show the previous slide once?
This one.
Yes, sir.
And so after this, for just a few seconds, could you show the slide before this as well?
Okay.
After this.
Sure.
Thank you.
Sit down.
Yes, sir. Done.
Okay. So in order to solve to identify a Pareto optimal point in the domain of production, we want to introduce the concept of an Edgeworth-Bowley box. Okay. The concept is very easy. That suppose we have 100 units of labor and 80 units of capital, we just draw a box like this, and this horizontal line is drawn till L equal to 100, and over here we draw K till 80. So this is, and then we can identify by a point the amount of labor and capital being used in the production of X. Right? Obviously, we cannot move beyond this area. So a point like this, for instance, why is this not feasible? We require more than 80 units of capital, and we have only 80 units. Similarly, a point like this, we have only 100 units of labor, but this implies that we are using more than 100 units. Okay. So we create it's not a box so far, it's just two sides of the box. But similarly, we can also prepare a half box for Y. What is the maximum amount that can be used for Y? 80 units of capital, 100 units of labor. So we have two half boxes like this, and in the third step what we do is, this is X, this is Y, and now we bring together these two half boxes to form a complete box like this. Is this clear?
So, yes, sir. So, can you show from the Edgeworth box slide?
Yeah.
Yes, sir. Done, sir.
Okay. Okay. Do you require this?
Yes, sir. One second. Done, sir.
Okay. So over here, what was the point that I was going to make? Well, over here we are showing how much of Y we are producing, right? And now we are bringing together the two boxes. Okay. So here we have the allocation of labor and capital for producing X. Here we have the labor capital allocation for producing Y. Okay. But when we bring the two boxes together, it becomes like this. And okay, now tell me that suppose the production of y is over here, and we are producing the production of x is the allocation of labor and capital is to x is given by this point. Is this an efficient point? And if so, why not?
Can you repeat the question, please?
So this point x indicates the allocation of labor and capital for producing x. This is the allocation of labor and capital for producing y. Now, is this allocation efficient? Is it possible?
No, sir. Sir, capital is not used.
Capital is not?
Completely used.
Yeah. So we have unemployed capital to the extent of x and y, this length. We are using only this amount of capital in y, only this amount of capital in x. So this is the unutilized capital. Okay. Now similarly for this point, x and y,
The unused labor.
this is unused labor. Okay. Now suppose this is the amount of this is the allocation for labor for y, and this is the allocation for capital. In this case, it's very easy to see that you have unutilized amounts of both labor and capital. Right? Do I need to show this?
No, sir.
It's obvious. I mean, this is the amount of unutilized capital. Oops, that easy. And this is the amount of unutilized labor. Okay, so we have all these allocations are involve some unutilized resources, either labor, either capital, or in the last case, both labor and capital are unutilized. So they cannot be Pareto optimal. Agreed? Now look at this. Is this Pareto optimal?
No, sir.
Why?
So again, the same thing, underutilized capital.
We have underutilized capital.
Sir, overutilized.
It's overutilized. How much of, remember, this is the x-axis. Wait a minute. And this is the y-axis. So how much of capital are we employing? This much. And in X industry, this is the amount of capital that we are employing. So if we sum them up, what are we going to get? Kx by ky is going to be greater than k bar. In this case,
Sir, can you show the point where both is underutilized once more?
this one. So this is unemployed labor. This is unutilized capital. Right? তোমার কতটা হচ্ছে এখানে? This is the amount of capital that you are using in Y. This is Kx, this is Ky. If I look at labor, this is Ly. Sorry, this is Lx and this is Ly. Have you finished?
Yes, sir.
Okay. So here you have overutilization of capital, and here you have overutilization of only labor. Capital is optimally utilized. And if you look at a point like this, then this is the amount of capital that you are using. So this is Kx and this is Ky. This is Lx. Sorry, it's very badly drawn. This is Ly. So this is the duplication. You are short of labor and capital by this amount. Don't draw all the diagrams, or if you draw it, at least draw it in separate Edgeworth-Bowley boxes. I'll just come back in 1 minute. Sorry. But at least it gave you time to finish the diagram. Okay, so we are having, these cases indicate overutilization of resources. So, can you, what does it imply about what can be a possible Pareto optimal point?
In the middle of the box.
No, see, if you think
Where the
carefully,
equality constants will strictly hold.
oh, obviously, that's obvious. When will the equality constraints hold? Can you tell me what is common between this set of points where you have overutilization and the earlier set of points where there was underutilization?
When they will converge to a single point.
Exactly. In both cases, x was at one point, y was at another point. If you are at different points, you can either have underutilization or overutilization, or even both. If you think about it, try to identify a point where you have underutilization of capital but overutilization of labor. Just try to find it out. You will see that if x is at one point on the Edgeworth-Bowley box, y is at another point on the Edgeworth-Bowley box, you cannot attain Pareto optimality. You will either have overutilization, underutilization, any of these problems, maybe both. So, for Pareto optimality, both producers must be at the same point. Let me just go back. I don't want to bring an additional thing. A very badly drawn box.
So could you show the previous slide once?
Yeah, I'll show it. Just let me finish my point.
Yes, sir.
See, suppose both x and y are over here. What happens? How much of capital are you using? This and this, right? So do you have, are you satisfying the equality constraint? Sorry, this should be k. Is this satisfied over here?
Yes.
Why so
Yes, sir.
hesitatingly? Now look at labor. What is happening? Again you have Lx Ly is equal to L. Right? You were talking about middle point. Consider a point like this. Even this point, both x and y are over here. Look at the distribution of labor. Is the equality constraint satisfied?
Yes, sir.
Capital, is it satisfied?
Yes, sir.
So it's not at the middle. We just require a very simple condition. Both x and y must be located at the same point. Got it?
Yes, sir.
Okay, now tell me which of these magnificent slides you wanted to see. This one or the one before that?
So there was a slide where there was a line Pareto optimal and then something else, something written. So that.
Oh,
yes,
only this. Just one word. One sentence.
Thank you, sir.
Okay. Now, we have this Edgeworth-Bowley box. Let us introduce isoquants over here. So we have OX So as we are going up like this, we are getting kx. If we are coming, okay, let's see, and as we are going like this, we have lx. Similarly, this is ky and this is ly, right? So let us introduce three isoquants for x. As we are moving like this, what is happening to the output level? If you are moving up like this, the
So
output.
for x it is increasing and for y it
Nah.
decreases.
For an, what is an isoquant? It is convex. So I have drawn it only for x, right? I'll come to y later. You're right, but I'll come to it later. So as we are moving up like this, what is happening to the output of x? It is increasing. Okay. Now let us bring in the isoquant of y. Okay. So if you want to look at an increase in output, we have to move like this. We have to move down. Okay, so let us say this is 100. This will be 150. This will be 225. This will be 300. On the other hand, if you want to look at y, this is, let us say 50, this is 70, and this is 90. Okay, is it clear? Now tell me, suppose Y industry, the producer Y is over here and the producer of X is over here, is at some other point. Can it be Pareto optimal?
No, sir.
Obviously not. As we have shown, both X and Y have to be at the same point. Now over here, this implies that the isoquants must be touching each other. This is a point. Both x and y are at the same point. This is another point. This is a third point, a fourth point. Okay. So all these are possible potential Pareto optimal points where both x and y are at the same point. Look, I've said potential because look at this carefully. Suppose I'm over here. Is it possible to increase the production of X keeping Y at the output level of 50? So Y is 50. Can we increase X from 300 to a higher output level?
Yes, sir.
Look at this isoquant. What is X? Well, more than 300. Let us say 300. Sorry. Let us say 320. So that means if I'm just talking about intersection, this cannot be a Pareto optimal point. I can move from here to here. I'm increasing the production of X. Can I do the opposite? So keeping X equal to 300, can I increase the production of Y from 50?
Yes, sir.
Just the opposite. I'm just showing for here. Okay, let me, yeah, it's better if I show it over here. See, production of Y has gone up, but X is same. So these intersections, when the isoquants are intersecting, cannot be Pareto optimal. So when I'm talking about that both X and Y have to be at the same point, it simply implied that there is no overutilization or underutilization of the resources. These are not Pareto optimal points. Right? It does not imply Pareto optimality. In fact, we have shown that.
So the Pareto superior.
Yeah, sorry, what did you say?
They are Pareto superior.
Yeah, this is Pareto superior to this. This is also Pareto superior to this. Right? So, let us work with this example. So my Y, I'm keeping Y as at 50. Can I increase X from 300? What was the answer?
Yes.
Yes, sir.
Yeah. So how much have I increased X to?
320.
Can I increase
20.
it further?
Yes, sir.
Yes, sir.
So we can do it till it's like a tangent to Y.
Yes, sir.
Very good.
Like forms like a X shape.
Yeah. So 350 is fine, but I can increase it and I come over here. Let us say X is 400. What happens if I increase it further?
So then Y's level of output has to increase.
Yeah. I am at this point. Y is at this point. X is at this point. You come back to overutilization, underutilization problem, right? You're violating this condition. You have to be at the same point. So the tangency of isoquants represent a Pareto optimal point. Or does it? See over here, let's come to over here. What happens? My X is at 225. Can I increase Y? And my answer was yes, I can increase Y. I can bring it to Y equal to 75. Can I increase Y still further? This one, Y is 77. And what is the limit? Again, tangency. So again, this is a tangency. Okay. So let us say that I have got a point. Let us say this is P2 and let us say this is P1. Which of them is Pareto optimal?
Sir, both. Like at the point of tangency.
Can't we compare them?
Yes, sir.
So
It's a partial comparative.
if we compare them, let's say we start from P1 and we move to P2. What is happening?
The proportion of quantities of X and Y is changing.
Not proportion. Be accurate, be simple. The output levels,
Yes, sir.
how is it increasing? How is it changing? Sorry. What is happening to X?
So it's reducing
X
from
is
1
Y.
to
Y is increasing.
and Y is increasing.
Exactly. If only X was increasing, or let us say X was falling, we could have said it was Pareto inferior. If only Y was increasing, we could say it was Pareto superior. But what is happening? One commodity is decreasing, the other is increasing. So these are Pareto non-comparable. Okay, that means both of them are Pareto optimal. You can increase the production of X only by reducing the production of Y. You can increase the production of Y, but X will then have to be reduced. I mean, just using the isoquants that I've drawn. Okay, I've drawn 4 isoquants for X. Are there other Pareto optimal points?
Yes, sir, like at the tangency of even the third one, the third set of
X equal to
isoquants.
150, X equal to 100.
Yes.
Can we have a Pareto optimal point over here when Y is equal to 90?
Yes, sir.
Now simply X is tangent. Right? Here also we have this. So I've just drawn 4 isoquants for X and 3 isoquants for Y, but actually we have a isoquant map. There are millions of isoquants drawn over here. So corresponding to each isoquant of X, we can identify a Pareto optimal point where the isoquant of Y is tangent to the isoquant for X. Okay, so we're moving like this and we come to here. So we have several points of tangencies, and let us suppose we draw a curve. It won't be a line, it will be an irregular curve. We draw a curve through all these tangency points. So this red line is the locus of all tangency points. This is called a contract curve. So a contract curve is the locus of all points where, can you finish this? What should I write after this?
Is the locus of all the Pareto efficient points. So basically where the tangency condition is met.
Right. So Pareto optimal conditions are satisfied, isoquants are tangent to each other, and if we are talking about tangencies, then this can be restated in a mathematical form. How can we write the second line? Isoquants are tangent to each other.
So the marginal rate of technical substitution is equal for both the commodities.
Yeah, tangency implies that slopes are equal, and we call the slope of an isoquant marginal rate of technical substitution. So be very careful of how you write it. MRTS, actually I've used subscript over here, it should be superscript X. So this indicates the output or industry, and this is labor and capital, the inputs. Okay. So in production, MRTS X equal to MRTS Y, this is the Pareto optimality conditions. We have found out, or we have operationalized Pareto optimality in the domain of production. We have defined a set of, we have defined a rule. Okay, do you want to see the earlier slide?
No, sir.
Okay. May I move to the next slide?
Yes, sir.
Okay. But one step backward. So we have the contract curve, and this has been drawn in for an Edgeworth-Bowley box. Okay. Now, if you map the production contract curve, because as you will see later on, we have a contract curve for consumers also. So if you map the production contract curve to output space, we will get the maximum possible combinations of X and Y that can be produced given technology and endowments. Okay, so I'll wait for you to write it down and then I'll move to the next slide.
Done, sir.
Yeah, everyone done?
Yes, sir.
Okay, but there's still left. So once we map it, see, the tangency was called, the locus of tangency is the production contract curve. Once we map it to output space, which means that we have the Edgeworth-Bowley box over here, this, the output space is this. So this is a graph where we have the output level of X on the horizontal axis and the output level of Y on the vertical axis. So over here we have different combinations of X and Y. Okay, so we find out what is the corresponding point over here. So here we see that X is very low, Y is very high. So this will be, let us say this is P1, P2, P3. I think 3 points are enough. This is P1. You're increasing X, so you're moving down like this. So P1, P2, P3. You have got points like this. So this is a production possibility frontier. If you are producing this amount of X, see in an Edgeworth-Bowley box, if you are producing this amount of X, what is the maximum amount of Y that you can produce? This amount. Okay, so I'm getting the production possibility frontier. given my technology, given endowments, this represents the frontier of my production possibilities. If I'm within the production possibility frontier or production possibility curve, I'm underutilizing resources, and if I go beyond the PPF, well, I require more resources or an improved technology.
So could you repeat the definition once again?
The definition of what?
So
PPF?
PPF.
But you know it, don't you? Or have you forgotten? MD taught it to you in the first semester, I think. It's the same PPF. I'll
Okay, sir.
repeat. I'll repeat it. Production possibility frontier indicates. In fact, it's written over here. This is the definition.
Okay, sir.
This is the maximum possible amounts of combination of X and Y. Okay, but remember that we have constraints. The constraints are technology, the constraints are input endowments. If the technology
Sir,
changes, if the endowment changes, I can move beyond the PPF. Yes, sir. Interrupted.
sir, A line ter माने कि if we map the production contract curve to output space,
Okay, let me. একটু আমি it won't be very visible. See, this is the Edgeworth-Bowley box. OX, OY, and I'm getting a this is the contract curve. Achha. What is the information that I am getting in the contract curve? I'm getting the following information. What is LX? What is LY? What is Kx? What is Ky? And third, what is the output level? Right? Suppose I'm taking a point like this. Can you tell me how labor is distributed between the two industries? Obviously you can't show it over here, but we can find. We know how much. What is Lx and what is Ly?
yes, sir.
Similarly, we know what is Kx and Ky.
हाँ, sir.
Are X and Y ta ki? We just have to look at the isoquants. Right? Achha.
हाँ, sir.
Now, suppose the combination of X and Y is 1050 over here. Or let's make it even higher. So this is X, this is Y. This is P2. What is the output combination over here? Let us say it is 50 and 250. And let us say this is P3. over here this is output space. Why output space? I'm simply denoting the output combinations in this graph. So the Edgeworth-Bowley box gives me all these, but only this information is used to construct the output space. But the combinations of x and y. Now what is P1? It is 10. What is Y? 500. So P1 is a point like this. Sorry, it's not very easily drawn. Okay, I hope you can see P1. How will I draw P2? I have to find out 50 over here and 250 in this axis. This will be roughly midway. Sorry. This is P2. How do I draw P3? X has gone up to 190. And what is Y? It has fallen to 25. Okay.
Okay, sir.
Now the locus of all these points, these output combinations, is my production possibility frontier. Unlike the contract curve, which is irregular in shape, the PPF is a concave curve. Okay, so the contract curve from the Edgeworth-Bowley production box can be mapped to output space to get the PPF. So if we take a point over here, any point on the PPF, what do we get? We get an output combination. We get a certain amount of X, a certain amount of Y. And we can draw an Edgeworth-Bowley box, not for production, but for consumption. So the red is the Edgeworth-Bowley box, corresponding to, let us say, P1. So P1 on the contract curve is mapped onto the PPF and we draw a Edgeworth-Bowley box. Now what happens is, do we have labor and capital over here? What do we have over here? What is this? What is this?
So amount of X produced,
And this?
amount of Y.
Amount of Y. So now, instead of OX and OY, so we have a certain amount of X and Y, and remember there were two people, A and B, who were sitting quietly, waiting for their turn. And now they put up their hand and say, class, I was waiting very patiently for our commodities. We need our commodity bundles. So you have produced X and Y. Please distribute this or allocate this between us. So you have produced P1, you have got a certain amount of X. You have got a certain amount of Y, and now they are clamoring that, okay, give us our share of X, give us our share of y. So you have to decide what is xa, ya. You also have to decide what is xb and y. These now have to be determined. Okay. Now we have drawn it for P1, but keep in mind that we can draw it for the Edgeworth-Bowley box for another possible point also. So this was P1. If we take another point P2, I can draw another Edgeworth-Bowley box for consumption. So if I take P3, I will get a third Edgeworth-Bowley box. And so in this way, corresponding to every point on the production possibility frontier, I can draw an Edgeworth-Bowley box for the consumers. I get a certain amount of X, this varies. I get a certain amount of Y, that will also vary, but I have to distribute this. Right?
স্যার ওই সেম বক্সে সব পয়েন্টগুলো প্লট করা যাবে না?
তোমার what is X? What does P1 imply? Look at the information over here, or look at this point. Are the boxes same? What is different between P1 and P2?
The combination of L and Y is different. The output levels are different.
Exactly. So when I'm looking at P1, well, I hope I am getting it correctly. 10 ছিল তো? I do remember Y was 500.
Yes, sir.
Sorry, this should be Y. This is at P1. If I go to P3, if I go to P3, then what do I get? What is X? I think Y was 190.
So 190 and 25. So it's the reverse.
Right. That is why we can't use the same Edgeworth-Bowley box. Your total amount of X, the amount of X that has to be distributed, the amount of Y that has to be distributed, that is different. In case of production, the advantage was that you had L bar and K bar. You simply have to distribute this. In case of consumption, your X and Y combination can change. The maximum amount of X and Y varies along the ppf. So you have different points, you have different Edgeworth-Bowley box. Does it answer your question?
আচ্ছা মানে স্যার এই এজওয়ার্থ-বাউলি বক্সটা মানে প্রোডাকশনের না কনজাম্পশনের?
This is for consumption.
ওকে ওকে, থ্যাংক ইউ স্যার.
Okay. What will be the Pareto? Take a particular point P1 and we just look at the Edgeworth-Bowley box. What will be the Pareto optimal points? Obviously, now what you have is, what will I write over here? What is the origin? Is it OX? Can it be OX?
OA.
It will be OA. What are you distributing between? And what is in this axis? Vertical?
Output level of maximum output of X and maximum output of Y.
Yeah, this is the output of Y and this is the output of X. So as we move from P1 to P2, P3, etc., the dimensions of this box will change. You can see over here. See over here, as we are moving down from P1 to P3, the height of the box is coming down, the length of the box is going up. And it's not a rectangular hyperbola also. Okay. So we bring in the isoquant. Again, it's the same pattern that if you move up like this, it's not isoquant, it should be indifference curve. So we have indifference curve. As we move up like this, we are looking at higher indifference curves for for A. And as we are moving down like this, we have higher indifference curves for B. B's utility is increasing. Okay. Now, would you say that there is cooperation? What is the situation? Cooperation or conflict? Is it a zero
So
sum
could you
game?
repeat the question once?
I'm asking, is it a zero sum game? When I'm distributing x between the
Yes, sir.
A and B, is it a zero sum game? Yeah, what did you say?
Yes, sir.
Yeah. So if it's a zero sum game, is there a conflict between A and B?
So technically it should be.
Yeah, I mean, obviously you want to improve your utility, right? If I consider you to be an out and out selfish person, what is your what is your objective? If you look at the consumer theory which MD taught you, what is the objective function of a consumer? How do we form the Lagrangian? Have you forgotten all of it? Simple. I'm not asking very complex questions. Just these are very simple answers. What is the objective of a consumer? What is his objective function? Don't worry about welfare. Go back to micro. Your first sem, third sem. Prithviraj? ক্লাস শেষ হয়নি। Yeah, I can't log back in. I mean, I'm trying, I'll wait for 2-3 minutes. Otherwise, I'll have to stop the class. Yeah, I'll let you know.